All right, welcome everybody. Today we're going to talk about lesson number 66. This is still section 5.4, but today we're going to talk about exponential function integration. Basically here, it's U substitution for life. Every time we've been doing integration for the last couple of months, actually, we've been using U substitution. So generally speaking, from this point forward, when in doubt, use U substitution. Today is only about indefinite integrals, which means they're all going to end with a plus C. We're going to go over the exponential integration rules. We're also going to be reminded of the natural log integration rules, since we tend to see a little bit of a mix of logs as well as exponentials. There you have homework number 66. Again, we're focused here on quality over quantity as we head towards the end of the year. So make sure that you keep that in mind as you do these assignments. First, just a little bit of a reminder. Just note that we did skip section 5.3 because it was just a review of inverses. 5.4 is what we're going to cover in lessons 11 through 13. And then we're going to finish up with section 5.5, and that will be it for chapter 5. So first, a quick review. The first two, these are a reminder of the two integration rules that involve ln's. While technically we are now in the exponential function section, don't forget that the ln rules are still a thing and they might pop up from time to time. Then if you were to look at your green sheet, you'll see there are actually only 3 formulas left that we haven't gone over yet. And here are 2 of them. Can you believe that we are going to finish the green sheet in the next couple of days? Very exciting indeed. Notice that the first equation on the left here, this is how you would integrate something simple, which is just e to the x, and you would integrate it very simply, e to the x plus c. If you have a more complicated version of e to the u, du, you're going to integrate it as e to the u plus c. Remember again that whenever you're doing u substitution, in this case, you're going to look for the u for the majority of the problems up in the exponent. And of course, if there is more or less than what the exact derivative of u is, then of course you have to go ahead and make a compensation. So let's go ahead and dive in here with number 1. So this is the integration of 2 times e to the x dx. Even though there's a 2 here, please note that that is just a constant, so it actually doesn't affect the rules. We're going to go ahead and start by pulling the constant out. So this is 2 times the integration of e to the x dx. Notice over here in the bottom right-hand corner, because it's just e to the x, a single 1x, that's how I know that I don't need to use substitution, and I can just go ahead and integrate using the rule. So if I want to integrate 2 times the integration of e to the x dx, I'm going to leave the constant 2 out front. According to this formula, the integration of e to the x is just e to the x, and I'm going to go ahead and finish it off with a plus c. As always, and maybe for these problems in particular, because of the way that you're doing the assessment, you should absolutely be checking all of your answers by taking the derivative and making sure that you can, in fact, get exactly back to the original answer. Remember, of course, as always, you can check any integration problem by taking the derivative. You can check any derivative problem by performing the integration. So that, more than ever, as the year winds down, I think is really a great technique that you should be employing. Notice that here in number 2, the problem is slightly more difficult because of the fact that inside here, you do not have just a simple x, but instead you have a 2x. So if you have anything other than a simple x, you're going to have to go ahead and do u substitution, which means that in this particular problem, u is equal to 2x. You're going to go ahead and take the derivative of both sides. Remember, of course, the derivative of u is du. The derivative of 2x is 2, and then don't forget dx. You're going to resolve the problem for dx equals, which in this case would be dx equals du over 2. Go back to your original problem, so keep the integration sign. Here's the original 2 from the problem. You're going to take e to the 2x and replace it with e to the u. You're going to replace dx with du over 2. Notice that here, the 2's are going to cancel, which means you're going to just be left with the integration of e to the u du. That's the best case scenario. So if you're trying to integrate e to the u du, according to the formula here, it's simply going to be e to the u. And in your final answer, replace the u with the original value of x's. And then, of course, don't forget the plus c. And certainly for these easier examples, I would strongly recommend you pause it, maybe go and try to take the derivative and make sure that you could get it back to equal the original problem. Here in number 3, so e to the x plus x dx. The parentheses are there just to make sure you're aware that each of them has a dx. So even though there are 2 different terms here, this is actually quite a simple problem. Because this is just e to the x, you can simply integrate it as e to the x. And then this is x to the first. Something that I saw on the last quiz is that with all these complicated rules we've been teaching you, some people have forgotten how to integrate the easy stuff. So try not to do that. So I don't have any u substitution or any work to do here. I'm free to just integrate away. So how do you integrate just e to the x? Well, that just becomes e to the x. How do you integrate x to the first? Remember our old friend, the power rule? You're going to raise x to the 1 higher power, which is 2, divided by that power, which is 2. And remember, you could also write that as half. And then, of course, don't forget all these problems need a plus c. And that's it. But again, don't forget how to integrate the easy stuff like x, because that was something that people seem to have a little bit of trouble with on the most recent assessment. The problems are going to get a little bit harder, but this is kind of the general idea here. Identify u, solve for du, and then go ahead and integrate. So e to the 3x plus 1 dx, we're going to go ahead and identify the fact that this is not a simple x, which means u substitution. So u equals 3x plus 1. Du would equal 3 dx, and of course the derivative of 1 is 0. That would mean that dx would be equal to du over 3. If I go ahead and rewrite my problem, so this becomes the integration of e to the u, and then du over 3. The 3 doesn't cancel, which is perfectly fine. That means I'm going to pull the constant out as a 1/3. And then I'm left with 1/3 times the integration of e to the u du. Time to integrate, leave the 1/3. Integration of e to the u is just e to the u. And in your final answer, replace the u with the original values of x, which is 3x plus 1. And don't forget to finish it off with a plus c. Remember, as we go through these problems, if you're feeling confident, you could always pause and try it. But again, I do want to make sure that I show you a good selection. So here in number 5, you're being asked to integrate this entire thing. Just be careful. Product rule, quotient rule, power rule, those are all for derivatives. These are all integration, so don't get it twisted. Here, if you are trying to identify u, so long as there is an e to the something, you're going to assume that that is the more complicated thing, certainly compared to 5x. And then you're going to choose what's inside the function up in the exponent. So that's going to be our u, negative x squared. That would mean that du would be equal to negative 2x dx, which would mean that dx is equal to du over negative 2x. As I go to rewrite here, I'm going to leave the original 5x. E to the negative x squared now becomes e to the u, and I'm going to replace dx with du over negative 2x. Notice here we are super lucky that the x's actually cancel out. Remember, if the variables don't cancel out, you have to do that long process of substituting in again. I don't think we gave you any of those in this section, so you're welcome. Because I have a 5 on top and a negative 2 on the bottom, I'm going to pull that constant out, negative 5/2. And that's simply going to leave me with the integration of e to the u du. Makes it nice and simple here. My answer is negative 5/2. Integration of e to the u is e to the u. And in the final answer, negative 5/2. Replace the u with the original value of x, which is negative x squared. And of course, don't forget about the plus c. So if you've been following u substitution all along here, this is really just more of the same. But again, practice never hurt anybody. We have 10 problems total, so let's keep on going. You can see the problems are getting slightly more difficult here in number 6. So you got a little bit of fraction action, but again, do not get it twisted. We're not using quotient rule or anything like that. That is only for derivatives, which this is not. So if you were going to try to choose where the u is, you're again going to look for the more complicated thing, which I think we could agree is e to the 1 over x. And then in addition to that, you're going to go ahead and make sure that you make the u whatever is inside the exponent. So u is equal to 1 over x. But I certainly am going to want to rewrite that as x to the negative 1. Much easier to take the derivative of x to the negative 1 compared to 1 over x. So the derivative of u, du, bring down the -1, then x to the 1 less power, which is -2. Remember, you're taking derivatives in this step, so you're going down. Don't forget the dx. I'm going to rewrite this problem so that it has a negative exponent. So I am going to leave the dx and the negative on top, but I'm going to move the x squared to the bottom, which makes it into a positive. I then want to solve for dx. So I'm going to go ahead and cross multiply. So I'm going to get du x squared is equal to negative dx, which means ultimately that dx is equal to negative x squared du. And that's kind of the most important part there. So as I go to rewrite this problem, so e to the 1 over x becomes e to the u, still over the original x squared. Replace the dx with negative x squared du. Look at that. Can you believe it? The x squareds cancel out, and we're simply left with the integration of negative e to the u du. And again, because we're kind of getting towards the end of the chapter, towards the end of the year, we're really trying to keep the problems on the easier side. So the x's should be canceling out. So if they don't, that's probably a clue to you that something went awry in this step over here. The integration of negative e to the u, don't forget that a negative is really just a constant of -1. So if you're going to integrate, leave the negative. Integration of e to the u is e to the u. In your final answer, don't forget to replace the u with what it was originally equal to, which in this case is 1 over x. And then, of course, don't forget the plus c. As always, you should be using your green sheet often. And again, after today, there's just one formula left, which is going to be coming next week. Okay, number 7, again, changing it up a little bit here. We've got some sines and we've got some cosines, but for now, we're going to focus on where the e is, and we're going to focus on our u being whatever is up in the exponent. So in this case, u would be equal to the cosine of x. Use your green sheet on the derivative side. The derivative of the cosine of x is the negative sine of x, and don't forget the dx, which would mean that dx is equal to du over negative sine of x. So here, if you leave the original sign, change it as e to the u, and then replace the dx with du over negative sine. The magic happens, canceling out those signs, leaving you with the integration of negative e to the u du. Again, that negative on the outside is really just a constant of -1. So leave the negative, integrate e to the u as e to the u, and in your final step, replace the u back with the original values of x, and don't forget about the plus c. So negative e to the cosine of x plus c, that is, of course, your answer. Couple problems to go here. So number 8, again, take a look carefully. Even though it looks like multiplication, we're not thinking product rule. That's for derivatives only. So look at the e to the x and look at the cosine of e to the x. If you're trying to figure out which one is more complicated, you're going to look at the cosine of e to the x. And then more specifically, you're actually going to look inside of the cosine. Remember back when we were first doing u substitution, you're going to try to identify the more complicated piece, which in this case is the cosine of e to the x. Then you're going to make u the innermost function, which in this case actually is e to the x. So we're going to make our u equal to this e to the x. Then du is equal to, again, use your green sheet as needed. The derivative of e to the x is simply e to the x dx, which means that dx is equal to du over e to the x. And that turns out to be an extremely good thing, because now when I go to rewrite my problem, I have the original e to the x. Now I have the cosine of u, and then my dx is equal to du over e to the x. So again, the magic happens by canceling out those e to the x's. And it turns out this isn't really an e problem, but it's really more of a cosine problem. So I'm trying to integrate the cosine of u du. Again, use your green sheet as needed. The integration of the positive cosine of something is the positive sine of the same something. In your final answer, replace the u, and don't forget the plus c. For our final two examples here, you want to be mindful about who u is going to be and whether or not you're able to use the power rule or whether you have to use the ln rule. You're going to use the ln rule if there is a fraction and if whatever is in the denominator is only to the first power. That is how you know that it's going to be an ln situation, whereas if your denominator was any other power, that's how you know that you would use the power rule. So again, taking a look at this fraction, you have more than one e to the x. So how do you know which one to make the u? Well, again, look at the top, look at the bottom, look for what is the more complicated piece. So because the more complicated piece is on the bottom, we're actually going to make that entire thing our u. Again, when you look at a fraction, you kind of want to think about the ln rules. And remember, for the ln rules, we almost always made the denominator our u. So du is equal to, the derivative of 1 is 0. The derivative of e to the x is e to the x dx. That is going to imply that dx is equal to du over e to the x. So take a look here what happens when we rewrite. So we have e to the x on top that was originally there. Then on the bottom, we have u. Dx is equal to du over e to the x. And because the e to the x is canceled, this actually becomes the integration of 1 over u du. And that is what we spent all our time in section 5.2 on. So again, go back to your green sheet. Look on the side with the integration rules. How do you integrate 1 over u du? Remember that that's going to be equal to the ln of the absolute value of u. In your final answer, ln, plug back in whatever the original u was, and don't forget about the plus c. So just because we've moved later in the chapter, don't forget about those old rules. And then our final problem of the day, this is maybe as hard as it would get. So first of all, it's a fraction. Second of all, there are e's on the top and bottom. Third of all, the bottom is raised to the 10th power. If your denominator is raised to anything other than a power of 1, that's a clue to you that you're going to be using the power rule as opposed to using the ln rule. So kind of keep that in mind. Look at the top, look at the bottom. You have to choose a u. And because of the fact that the entire bottom is in the power of 10, we're going to make the entire bottom e to the x plus 5. That's going to be our u. Du is equal to e to the x dx. And again, the derivative of a constant is always 0. So dx is going to be equal to du over e to the x. When we go to simplify, we have 3 e to the x on top. Then we have u to the 10th on the bottom. Then we have du over e to the x when we sub that in for dx. So I'm going to cancel out these e to the x's. Notice that I have a 3 there, so don't forget that the 3 is there. And then I don't like to have any powers on the bottom. Those are hard to integrate. So I'm, of course, going to move it up to the top by making it u to the negative 10. So looking at this problem right here, now that I've identified all the different steps, this is actually not an ln integration, and it's actually not even an e integration. This is just a power rule integration. So that's why it's very important that you take your time realizing who the u is. So how do you integrate 3u to the negative 10? Well, leave the 3, raise the u to the 1 higher power, which is negative 9, divided by that same power, which is negative 9. 3 over negative 9 becomes negative 1/3. I'm going to move the u to the bottom and turn it back positive. So my final answer, negative 1 on top, 3 on the bottom. Replace the u with e to the x plus 5 to the 9th, and then don't forget about the plus c.